In this video, we're going to talk about quadratic applications. In the first example, it says, among the pairs of numbers whose difference is 4, find the pair with the smallest product. So we want to find the pair of numbers whose difference is 4, and when I multiply them together, it's going to give me the smallest product. So I got to find that pair of numbers, and then I also got to find the product. What the actual number is, what you get when you multiply them together. So if we think of our pairs of numbers as ordered pairs, think of x as the first number and y as the second number. But y is going to be specifically, remember, a difference of 4 from x. So I'm going to rewrite this so I have everything in terms of x. Y is going to be x minus 4 because it's a difference of 4 from x. So here's all of my pairs. Now it says if I multiply those pairs, I want to find what the smallest product would be. So if I create a quadratic function, x times x minus 4, if I distribute that x, I know it's a quadratic because it's degree 2, I got a squared, and now it's in general form where my value of c is 0, my a is 1. So I know I'm going to have a graph that looks like this. And it's asking me for the smallest product. So that means I'm looking for my minimum value, which is my vertex. Whenever we're dealing with quadratics and it asks me to find the minimum or the maximum, what we're looking for is that vertex. So I need to find the vertex. So I'm going to use my vertex formula. So I have minus b over 2a. So my b is negative 4. So I have a negative 4. That's a positive 4. Over 2a, which is 2 times 1, which is 2. So my h is going to be 2. Now I got to plug back in to find my corresponding value of k. When I plug the 2 in, that's going to give me a 2 times a negative 2, which is a negative 4. So my vertex is going to be at the point 2, negative 4. So this should be the pair that gives me the smallest product. And that product, if I multiply it together, that would be 2 times negative 4, which would be a negative 8. So this is my smallest product. And this is the pair of numbers that would do that. Okay, next example, it says find the dimensions of a rectangular corral producing the greatest enclosed area. This is asking for the greatest enclosed area. So now when we're looking at this, we're going to try to find a maximum value, which means when I set up my equation, I should have an equation that shows me that I have an upside down, a concave down quadratic in order for me to get a maximum point at the top. Okay, so if you imagine you have a corral, it's rectangular, so I'm going to call the width x and, the length x and the width y. It says that it is enclosed by 240 feet of fencing. That means that if I take 2y, right, because I have two sides that are length y, and I take 2x, because I have two sides that are length x, and I add it up, that should give me 240 feet of fencing. That's my perimeter. We want to find the maximum area. An area would be when I take length times width. So my area is going to be x times y. Well, we can't solve anything with a y in there. We have to have all x's or all y's. So what I'm going to do is I'm going to solve this equation here for y so I can plug it in here and have everything in terms of x. So when I solve this equation for y, that's my perimeter, I have 2y is equal to 240 minus 2x. Then I'm going to divide everything by 2, so that gives me 120 minus x. So y is equal to 120 minus x. So I'm going to replace that y in my area equation with 120 minus x. And now when I multiply through to see what my equation looks like in general form, I get 120x minus x squared. And then I can put it in descending order and rearrange it so that I have my x squared in front. And I get negative x squared plus 120x. And this tells me I'm on the right track, because remember, if we want a maximum value at the top here, it's got to be an upside down quadratic. And this negative in front here tells me it's going to be an upside down quadratic. So it looks like we're on the right track. So if I want to find that maximum area, I need to find that vertex. Okay, so to find the vertex, that's my x coordinate. My h is my x coordinate of the vertex, and that's minus b over 2a. And let's see, if I look at it in general form, my b is 120, and my a is negative 1, so I have 2 times the negative 1. So I have negative 20 over negative 2, which is a positive 60. So my x is 60, and that is in feet. So now I got to plug back in over here to find out what my y value is, or my width. So when I take 120 minus 60, that's going to also be 60. So my y is additionally 60 feet. Let me see. I'm going to write this in a different color so it's easier to read. It's starting to get cluttered. Okay, so I have my x is 60 feet, my y is 60 feet, and remember, I got the 60 feet in this y by taking 60 and plugging it in for that x, so I get 120 minus 60. So my dimensions are going to be 60 feet by 60 feet.